Every time you open Netflix, something strange happens. Within seconds, the platform seems to know exactly what you might want to watch. A crime thriller appears on your homepage. A new series pops up under Top Picks for You, and somehow, it feels perfectly timed. But here's the real question. Out of thousands of movies and shows, how did Netflix decide those exact titles were the ones you should see? Is it random, or is there something far more sophisticated happening behind the screen? The truth is, Netflix is powered by one of the most advanced recommendation systems ever built, a system driven by algorithms, machine learning, and billions of viewer interactions every single day. In this video, we're going to break down how this system actually works, how Netflix studies viewer behavior, how it predicts what you might watch next, and why this algorithm has become one of the most powerful competitive advantages in the entire streaming industry. Because Netflix isn't just a streaming platform anymore, it's an AI-powered discovery engine for entertainment. Before we begin, welcome to Strategy Lens, a channel where we break down the technology and strategies behind the world's most powerful companies. If you enjoy deep dives into business, technology, and innovation, consider subscribing to the channel so you don't miss the next case study. Now let's take a closer look at how Netflix's recommendation engine actually works. At first glance, Netflix looks simple. You open the app, you see rows of shows, and you pick something to watch. But behind that simple interface lies a massive challenge. Today, Netflix hosts thousands of movies and TV shows, and every year, that library keeps growing. Now imagine being a viewer. You open the platform after a long day, and you're suddenly faced with an ocean of content. Too many choices can actually create the opposite of convenience. Instead of watching something, people start scrolling, searching, and eventually giving up. This is known as the paradox of choice. For Netflix, this creates a serious business problem. If viewers spend too long searching for something to watch, engagement drops. And in the streaming industry, engagement is everything. The longer viewers stay on the platform, the more valuable the service becomes. So Netflix needed a solution, not just a content library, but a system that could instantly help every viewer discover something they would enjoy. The answer to that challenge became the Netflix recommendation algorithm. Before we understand how Netflix solves this problem, we need to understand two important concepts. The first one is algorithms. An algorithm may sound complicated, but the idea is actually simple. An algorithm is just a set of step-by-step instructions used to solve a problem or make a decision. In fact, you interact with algorithms every single day. Search results on Google, navigation routes on Google Maps, product suggestions on Amazon. Each of these platforms uses algorithms to determine what information should appear first. But over the last decade, another concept has become even more powerful: machine learning. Machine learning is essentially an advanced form of algorithm. Instead of following fixed rules, machine learning systems learn patterns from data. Think about it like human experience. Imagine you come home late at night. Before anyone even says a word, you already have an idea of how your parents might react. Your brain learned those patterns from past experiences. Machine learning works in a similar way. Instead of programming exact instructions, engineers build systems that learn from millions of examples. For example, a traditional algorithm might say, if a user likes action movies, recommend action movies. But a machine learning system does something much more powerful. It analyzes millions of viewers, detects hidden patterns, and predicts what someone might watch next. So, in simple terms, machine learning, algorithms that learn from data. And for a platform like Netflix, with hundreds of millions of viewers, that idea becomes incredibly powerful. One common misconception is that Netflix runs on a single recommendation algorithm. But in reality, the system is much more complex. Netflix operates thousands of machine learning models simultaneously. Every single day, the platform processes billions of viewer interactions. Every click, every search, every pause, even every moment you hover over a show. All of it becomes data, and that data feeds the recommendation engine. To understand how the system works, we can break it down into several stages. Everything begins with data. Whenever you interact with Netflix, the platform collects behavioral signals that help it understand your viewing habits. These signals include what you watch, how long you watch, whether you finish an episode, if you pause or rewind, if you binge multiple episodes. The system also observes your search queries, your ratings, the time of day you watch, and even which device you use, TV, phone, or laptop. Even something as simple as hovering over a show can be recorded as a signal. When millions of viewers generate billions of these signals every day, Netflix gains an incredibly detailed picture of how audiences behave. And this data becomes the foundation of the recommendation system. Step 2. Machine learning models analyze the data. Once this data is collected, machine learning models begin analyzing it. These models study massive datasets to identify patterns in viewer behavior. For example, the system might discover that viewers who watch crime dramas late at night often enjoy psychological thrillers, or that viewers who binge historical dramas frequently move on to fantasy series. These patterns are not manually programmed by engineers. Instead, the system learns them automatically by analyzing the behavior of millions of users. But to generate recommendations, Netflix uses several different techniques. One of the most important techniques used in recommendation systems is called collaborative filtering. This method compares viewers with similar tastes. Imagine two viewers. User A and user B have watched many of the same shows. Because their viewing histories look similar, the algorithm assumes they might enjoy similar content in the future. So if user A discovers a new series, the system may recommend that same show to user B. In other words, the recommendation is based on the behavior of similar users. Another technique Netflix uses is content-based filtering. Instead of comparing viewers with each other, this method analyzes the characteristics of the content itself. Every show on Netflix can be described using attributes such as genre, actors, director, story pacing, tone, language, themes. If someone frequently watches dark crime thrillers, the algorithm learns to recommend other shows with similar attributes. This ensures recommendations stay aligned with the viewer's taste in storytelling. As Netflix expanded, its recommendation system evolved further. Today, the company also uses deep learning models. Deep learning systems use neural networks capable of analyzing extremely complex patterns. These models study behavior such as viewing sequences, binge-watching patterns, episode completion rates, user engagement levels. For example, the system may learn that viewers who watch 3 episodes in a single evening are highly likely to finish the entire season. These insights allow the platform to predict future viewing behavior. Another technique used in modern recommendation systems is reinforcement learning. In this approach, the algorithm continuously improves by observing how users respond to recommendations. Every suggestion becomes a small experiment. If a viewer clicks and watches a show, the algorithm learns that the recommendation worked. If the viewer ignores it repeatedly, the system reduces the probability of recommending similar content. Over time, this feedback loop allows the algorithm to constantly refine its predictions. But perhaps the most important step in the entire system is ranking. At any moment, Netflix may have thousands of possible titles it could recommend to you. The ranking system decides which shows appear on your homepage, which row they appear in, and the order in which they appear. Even the thumbnail images are personalized. If you often watch romantic films, the thumbnail might show a romantic scene. If you prefer action movies, the same title might appear with an intense action shot. These small details dramatically increase the chances that you will click and start watching. Running this recommendation system requires enormous computing power. Most of Netflix's infrastructure runs on cloud services provided by Amazon Web Services. The platform stores massive amounts of viewing data using technologies like Amazon S3, Cassandra, MySQL. To process this data, Netflix relies on systems such as Apache Spark, Apache Kafka, Apache Hadoop. These systems process petabytes of viewing data every single day. Netflix engineers have also built internal tools such as Metaflow, designed to manage large-scale machine learning workflows. Inside the Netflix app, all this complexity appears as a simple homepage. Rows such as top picks for you because you watched, trending now. Each row is generated dynamically using machine learning models. And the algorithm never stops evolving. Viewer preferences change constantly. To keep recommendations accurate, Netflix continuously retrains its machine learning models using fresh data. Despite its sophistication, the Netflix recommendation system still faces several challenges. One of the most common issues is the filter bubble problem. Because the system prioritizes engagement, it often recommends similar types of content repeatedly. For example, if a viewer watches several crime shows, Netflix may continue recommending more crime content. While this improves engagement, it can limit exposure to other genres. Another limitation is the cold start problem. When a new user joins Netflix, the algorithm initially knows very little about their preferences. Without enough data, early recommendations may feel generic. The same issue affects new shows and movies. Without viewer interaction data, the algorithm may struggle to determine which audience would enjoy the content. Another challenge is popularity bias. Highly popular shows receive more engagement, which causes the algorithm to recommend them even more frequently. This can create a feedback loop where big titles dominate visibility while smaller productions struggle to be discovered. If we approach this system from a consulting perspective, several improvements could enhance the recommendation engine. One idea would be introducing a controlled exploration layer. Instead of only recommending highly predicted content, the system could occasionally introduce new genres, international shows, or emerging creators. Another improvement could involve a stronger onboarding process for new users, allowing viewers to select preferred genres, actors, or themes during sign-up could help generate better recommendations faster. To reduce popularity bias, Netflix could also introduce dedicated discovery slots that highlight underrated or emerging content. Ultimately, recommendation systems don't just predict behavior, they shape how people discover stories. And in the digital entertainment industry, discovery is one of the most powerful competitive advantages. And that's it for today's breakdown. If you'd like a deeper video explaining Netflix infrastructure or the technologies behind these algorithms, let me know in the comments. And if you enjoyed this breakdown, don't forget to like the video. It really helps the channel grow. Thanks for watching Strategy Lens. And I'll see you next Tuesday with another business and technology case study.